So this tutorial, we're going to take a look at coding our game manager. So let's take a look at three properties that we want to take a look at. We want to look at how many coins were collected. So let's look at coins collected as one variable. We'll do another one called, well, let's go ahead and just do a public here. Public float, coins collected. Put a semicolon here just to kind of close that off. Public float. Call this one coins to win, and we can set this to 10 for now, but you can do 10.0 because it's a float, and make sure to put an F behind it. Then we need one more, and this is our timer, so we can just call this time. You could even call it time to win, and again we'll just copy this 10F. Now what I'm going to do is introduce you to something completely new, and this is a built-in feature just like void update or void start, and it's called a coroutine. Just like void update runs every frame and void start runs just once, there's a feature called a coroutine, and what that does is it runs in parallel to any other process, and it'll actually span multiple frames. So we're going to actually write a timer that's going to control the amount of time our game is running. So let's go ahead and write this, and then we'll review it after we're done writing it. Now the first thing you do when you create a coroutine is you write the word public, and then you write the word IEnumerator. This is a data type, and this specifies that we're going to have a coroutine. We're going to do an open and close parentheses. Now we haven't named our coroutine yet, so let's go ahead and name this. Just like any other method, we want to name our coroutine with something that's, again, has a pretty important name that we know exactly what it does. So for example, this coroutine is going to be called start countdown. Okay? Now what's important about coroutines is you can have them start an action across multiple frames, or hold, or pretty much do anything time-based based on a specific condition. So let's say we want to yield, and we want to yield based on this time to win. So we're going to write return new wait for seconds, and inside of here we're going to put time to win. So what this line of code is actually doing is this. After we've run this enumerator, or this coroutine, is going to start the second our program runs. And when it runs, it's going to call this statement. Okay? Now our program is going to yield as it waits for a certain number of seconds that are based on a time. And we know that time to win is now 10. So let's go ahead and comment this. So wait until time has expired. So we're going to wait until time has expired before we do this next line of code, which is going to be an if statement. Now this if statement is going to check if coins to win is less than or equal to coins collected, or is greater than or equal to coins collected. Actually, what might be more interesting is if we reverse these. So I'm going to actually move this here, and I'll move this here. That might make better logic. So if the coins we've collected are greater than or equal to coins to win, we'll maybe send it to a screen that actually sends it to win. So that makes a little bit more sense. So if coins are collected are greater than or equal to coins to win, we'll do something. And again, this if statement isn't going to check if we won until after time to win has been done. Alright, so for now we'll just do a print statement here that says you won to test this. And then we'll throw an else statement here. And this else statement will print try again. Alright, I'm going to go ahead and save this. Alright, let's do one last thing. Now, in order to start a coroutine, and again, remember, you can identify a coroutine by having the IEnumerator object, is in the start of our game, we want to actually take our start countdown, paste it in our start function, and right now, if we save this, which I just did, it's not going to run. You actually have to, in C# explicitly state that you want to start a coroutine. You do that by writing start coroutine. Let's go ahead and wrap this, and I'm going to hit Control S. Now let's test it in Unity. I'm going to go ahead and press play, and after 10 seconds, we should get a message at the bottom saying that we lost. Let's open up our console. There we go. Alright, and let me get rid of this other camera so that we get rid of this audio listener message. Now the game manager, I'm going to make a game object, create an empty game object, and call this game manager. Now many of the tutorials you're going to find on the internet, you're going to find that they all create a game manager. And again, that controls the overall game. Alright, so we've got coins to win, coin collected 0. So let's press play and see if we wait for 10 seconds. And after 10 seconds, if we get an error saying that we did not win the game. There we go. See, it says try again on our screen. Okay? So let's take a look at a couple things now. Like, how do we actually get this so that when we walk up to a coin, we can collect them and they destroy from the scene? Right now, if we walk up to it, you'll notice that we get stopped because of the box collider on our object. What we can do is we can implement something called a trigger. So I'm going to put this a little bit closer, and I'm going to check on, I'm going to check on isTrigger. So now we can actually pass through our object. So this is kind of a nice method for, instead of having it do an onCollider, which we learned in the other tutorial, it's kind of a nice feature because it won't sort of jar our player as they bump into it and then it deletes. So let's go ahead, leave this trigger on, and let's look at our coin manager. And let's talk about how to code triggers. Now, we're going to use another pre-made method inside of Unity called onTriggerEnter. So let's go to our coin manager, and just above void start, or we could actually do this below void update, it doesn't really matter at this point. We're going to type void on trigger enter, open close parentheses, open close curly braces. Now, anything we do to a trigger, we can actually script in here. Now remember, this script is attached to our coin. So we can check if we're going to bump into objects called player or whatever and then do something. So let's go ahead and select our first person controller and make sure he's tagged as player. Now let's take a look at scripting this. The first thing we have to do is we have to pass a variable in here. So we're going to call this other. And this variable, other, can store any sort of information that we get when we bump into a collider. So if we say if other, so now we're saying if we bump into something and we're registering all the bumpers, and we'll use compare tag. This is a pretty good one. If our other object, and we'll compare a tag, is tagged with, so compare tag is a pre-existing method, player, we can just bump, we could do, here, we'll do a print, you collected coin. And then we can also do destroy, and then inside of here we can just do game object. Alright, I'm going to hit Control S. Let's see if this actually works. I'm going to walk into my coin. You collected a coin. No other coin is seen. Now, we know for a fact that these coins are prefabs, so we can just duplicate a bunch of these, and it's going to update the script will update on all of them. So we can kind of, and you know, in your game that you're gonna have to do for your homework assignment, you could build mountains and things like that, right? So I'm gonna hit Control S to save this scene, and let's go off and finish this off really quickly. On second thought, what we'll do is we'll end this video here. We hit a little bit over the 10-minute mark. And in the next video, we'll take a look at updating our game manager so that it takes into account all of the coin detection.